Okay, for this one, for example, 8, we have the following situation. We have a figure, we have a mass, we have a box. We don't know the mass, but they're giving us all these little variables in terms of m, k, and v. And they're telling us what happens when you double the mass, meaning when this box is sliding back and it's oscillating, reaches its equilibrium position, and you quickly add another mass on top of it. Since the box is already going at its maximum speed, when you add the box into it, the box also follows a bit of some changes. So first of all, okay, if the velocity max is still the same, meaning the moment you put the box on it, it was already going at its maximum velocity, so the box is going to be going at the same speed that you exerted it. So your kinetic energy is going to double. Double the mass, you double the kinetic energy, since the speed didn't decrease initially the moment you added it. And since all that kinetic energy is going to become potential energy, and potential energy is 1/2 kx, if you double the kinetic energy, then you double the potential energy. If you double the potential energy but you don't change the k, that means your displacement is going to increase by the factor of square root of 2. Or it's going to increase by a factor of 1.41. Again, the maximum velocity will still stay the same. And since the maximum velocity is equal to the amplitude times the angular frequency, and the velocity and the max stayed the same, and the angular frequency is going to change by a factor of square root of 2, so if the amplitude is increasing, then the angular frequency would have to decrease by the same factor to keep the velocity maximum from changing. So you would need to decrease the angular frequency by a factor of square root of 2, or multiply the original angular frequency by 1 over square root of 2, or 0.707 if you wanted to round. You could have also done it by figuring out that the angular frequency equals the square root of k over m. The k is not going to change, but if you double the mass, the angular frequency is going to decrease by a factor of square root of 2. So we get the same answer, same results. And that's it.